Hello friends, welcome to my channel Raji CS Revision Notes. Today we see some of the formula in the second unit, that is computer system architecture. So here this is a basic formula, that is just to know 1 bit is 1 binary digit, so 1 byte will be 8 bits, that is 2 power 3. So 8 bits means 2 power 3 bits. Then 1 kilobyte means 1024 bytes, that you can write as 2 to the power 10. Then 1 megabyte is equal to 1024 kilobytes. That's you can write as 2 to the power 10 bits, 20 bits. That is 1 gigabyte equal to 1024 megabytes. Means it is can write as 2 to the power 30 bits. So 1 terabyte equal to 1024 gigabyte, that is 2 to the power 40. So you can write 2 to the power 40 bits. 1 petabyte is equal to 1024 terabytes, that is 2 power 50 per 50 bits. So 1 exabyte is equal to 1024 petabytes. It will be about 2 to the power 60 bits. Okay. Next, pipelining. So what is formula for pipelining? So for a pipeline process, the time taken is be k plus n minus 1 into Tp, and time taken for non-pipeline processes n into Tn. So that means the speed up will be speed up of the pipeline process over the non-pipeline processes. S is equal to NTN by K plus N minus 1 into TP. What is N? N is the number of tasks. K will be number of segments. And TP is the pipeline process time, and non-pipeline process is TN. So in a multiplexer, so what will be the input lines and selection lines? For 2M input lines, there will be M selection lines. For any input lines, it requires log 2 N selection lines. Then ripple counter. So in ripple counter, you need to remember that for negative edge triggering means from 1 to 0. Positive edge triggering means 0 to 1. Okay, so change occurs from 1 to 0. And if when the positive edge triggering means change occurs from when moves from 0 to 1. So n-bit ripple counter counts 2 n states. So how will represent an encoder? Encoder represent as 2 pi n into n, that is 2 power n cross n. For 2 pi n inputs you get n output. For decoder, for n inputs you get 2 power n outputs. So memory capacity. So how will you represent memory capacity? Memory capacity is represented as 2m into n, where m is the number of address lines and n is the number of data lines. Next is signed representation range. So you need to know what is the range of the signed representation. So it is minus 2 to the power of n minus 1 minus 1 to plus 2 to the power of n minus 1 minus 1. So you need to know the range of the signed representation. So the same thing will be for 1's complement range. So minus 2 pi n minus 1 minus 1 to 2 pi n minus 1 minus 1. So you need to know the 2's complement range also. See, 2's complement range will be minus 2 pi n minus 1 to plus 2 pi n minus 1 minus 1. So this is very important because most of the questions will be asking in 2's complement. So it is minus 2 pi n minus 1 to plus 2 pi n minus 1 minus 1. So then what is the floating point representation? So 14-point representation can be represented in single precision or double precision. Single precision means 32 bits. Double precision means 64 bits. And this is the structure. We have a sign bit, exponent and mantissa part. Here for single precision it is 1, 8 and 23. For double precision it is 1, 11 and 52. Next, biased exponent for single precision, that is E is equal to E plus 127. Same thing, biased exponent for double precision means it is E equal to E plus 1023. So normalization. So here how to write it in the form? So default is implicit. So implicit will be first bit as sign bit. So minus 1 is into 1 point m. So we'll write as in form 1 point mantissa. It means mantissa. So 1 point mantissa into 2 pi e. It's just the implicit means is a default. If nothing is given, you can use this thing. Otherwise, if it is explicit scan means it's a sign bit, then 0 point m, that is 0 point mantissa into 2 pi. Next, you need to know the flip-flop characteristic equations. See, first one is set reset. So in set reset, what is the characteristic equation? Qn plus 1 is equal to s plus q1 into r dash. For jk flip-flop, qn plus 1 is j into qn dash plus qn into k dash. For d flip-flop it is qn plus 1 equal to d. For t flip-flop it is qn plus 1 is equal to t into qn dash plus t dash into qn. Next we'll see the next one, that is programming languages and computer graphics. Here we need to know the line drawing algorithms. So can use three main forms for line drawing algorithms. If you use use of line equation, just the line equation resource means that is y equal to mx plus b. You will write the slope, that is m is y2 minus y1 by x2 minus x1, that is dy by dx. So we have two conditions, that is if m less than equal to 1, then line move towards the x-axis and xk plus 1 is xk plus 1. Okay, if a line moves towards the y-axis, that is m, the slope is m greater than 1 means yk plus 1 is equal to yk plus 1. Next form is that you can use a DDA, that is digital differential analyzer. So here take the same slope, then when m less than equal to m, the conditions will be different. So when m less than equal to 1, then xk plus 1 is xk plus 1, yk plus 1 is equal to yk plus m. Next, when m greater than 1 means yk plus 1 will be yk plus 1 and xk plus 1 is equal to xk plus 1 by m. So this is how we use a DDA analyzer. So next, Bresenham line algorithm. Here you will use a decision parameter. You will use a decision parameter p is equal to 2 dy minus dx. So you know p is equal to 2 dy minus dx, and dy is what is y2 minus y1 and dx is x2 minus x1, and slope m is equal to dy by dx. Now we have two conditions, that is when m less than 1 and when m greater than equal to 1. So this condition will be different from the other two. So here only m less than 1 and other condition m greater than equal to 1. So for each of the condition you need to check the value of p, whether p is less than 0 and p is greater than equal to 0. So when p is less than 0, so within m less than 1 we have two conditions, that is the decision parameter. When p less than 0 means x will be x plus 1 and p is equal to p will be modified as p is equal to p plus 2 dy. Similarly, when p is greater than equal to 0, when p is greater than equal to 0, I hope this is clear. When p is greater than equal to 0, then x will be x plus 1 and y will be y plus 1, and p is equal to p plus 2 dy minus 2 dx. P equal p plus 2 dy minus 2 dx. Similarly, when m is greater than equal to 1, when the condition is m greater than equal to 1 means when p less than 0 means y will be y equal to y plus 1 and p will be p plus 2 dx. And then when p is greater than equal to 0, and p is greater than equal to 0, then x will be x plus 1 and y equal to y plus 1, and p value will be p is equal to p plus 2 dx minus 2 dy. So you need to know the formula so that you can able to solve problems quickly. Next, Besant circle algorithm. So what is the equation of circle? X minus xc x whole square plus y minus yc whole square equal to r square. Here in the case of circle we take x is 0 and y equal to r, this radius, and the deviation d is given by d is equal to 3 minus 2r. Here there are also two conditions, that is d less than 0 and d greater than equal to 0. When d is less than 0, then xi plus 1 will be xi plus 1 and di plus 1 will be di plus 4xi plus 6. Similarly, for when d is greater than equal to 0, xi plus 1 will be xi plus 1, yi plus 1 will be yi minus 1, and di plus 1 will be, di plus 1 will be di plus 4 into xi minus yi plus 10. Okay, please know this formula. Okay, next, in case of line clipping algorithm, so here you in case of this circle algorithm, you plot the points and then you find the values of x and y. You terminate only when x becomes greater than y in a circle means you terminate. That's why you terminate it. Next, for line clipping algorithm, here the you use this value to find the value of the other points in the window. Okay, so here you use y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. Yes, here also you need to remember some formula for, that is the values of sin theta and cos theta for the angles. Okay, I have given shown in this table, so it will be useful because when you have to solve the problems, you can use this table. Okay, sine theta will be 0 0, sine 30 is half, for sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Similarly, cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, and cos 90 is 0. Next, we go into the 2D transformations. So here you have translation. So first translation is x dash will be x plus tx, and y dash will be what? Y plus ty. So you need to remember both this form, how you transform this part, that is x and y new axis, as well as how to express this in the form of matrix also, which we need to know. See, x dash y dash 1 is a homogeneous type, so we put 1. So here the new coordinates will be 1 1 1 0, and tx and ty will come in the right. Okay, so 1 0 1 0 tx, 0 1 ty, and 0 0 1. Remember this in the diagonal will be 1 1 1, and write tx and ty in the right. Okay, and multiply by the present value of x and y, that is x y and 1. Next, for rotation. So rotation about the origin. So normally rotation about the anti-clockwise direction. It is a default one. So normally they give rotation means it is the anti-clockwise direction. So here the formula will be x is equal to r cos theta, y is equal to r sin theta. So the new coordinates will be x dash y dash will be equal to cos theta. Remember, cos theta minus sin theta cos theta. So other places we put 0 0 0 0 and 1, and x y and 1. Then rotation of the clockwise direction, so the opposite of this one. So we'll write x dash y dash, the new coordinates will be cos theta instead of sin theta plus sin theta, and instead of sin theta minus sin theta cos theta, and here 0 0 and here 0 0 1 of into, this is into x y and 1. Okay, next scaling. So scaling means increase that scale to big larger size. So x dash should be what in that size. What is the scaling factor? So sx is the scaling factor. So x dash is equal to sx dot x, y dash is equal to sy dot y. So if you use scaling to increase the size, so x dash will be sx into x, and y dash will be sy, the scaling factor, into y. So how we'll write in the matrix form, x dash y dash, this new coordinates will be sx, then sy, and then 1. So we'll write in the diagonal sx sy 1, and then others you fill with 0. Others and all are zeros of the old coordinates, that is x, y, and 1. Now if you want to decrease the size, if you want to scale to decrease the size, means the new coordinates will be x dash y dash 1 will be 1 by sx 1 by sy in the diagonal. Okay, and 1. Okay, and to of the old value, that is x, y, and 1. Next, reflection. So if we given reflection, it is about the x-axis, that is reflection about the x-axis, means you have to put a x positive and y will be negative. Okay, so new coordinates will be x dash y dash 1 will be 1. You have to here also use the diagonal only, see 1, and then y dash is my y dash is about x-axis, means y will be minus 1. So put minus 1 here and 1. Others are zeros into of the older coordinates, that is x, y, and 1. Similarly, about the y-axis is x-axis. It is about the y-axis, means we write minus 1, 1, and 1 of x, y, and 1. If it is about both x and y axis, with both x and y axis, then you have to write both the minus minus. So here in the diagonal, minus 1, and 1. Other places are 0. So new coordinates will be minus 1, 1, and of x, y, 1. So x, y was, it is the old coordinates, x dash, y dash is what new coordinates. Now for 3D transformations, it is similar to 2D only. See, only we add the new coordinate, that is plane, that is z. So x dash will be x plus tx, y dash will be y plus ty, z dash will be z plus tz. So all the matrix will be x dash, y dash, z dash. So this is the how will be the homogeneous matrix. So x dash, y dash, z dash 1 will be you write tx, ty, tz, and in the diagonals you write 1. So other diagonals you write 1, and other places you put zeros. So this is how the translation will be of the current coordinates, that is x, y, z, and 1. So this is how translation. Now for scaling. Now scaling means to increase the size means what will come, x dash will be sx into x, y dash will be xy into y, z dash will be zx into z. That is the scaling factor. Sx, xy, and z are the scaling factors. So new coordinates will be how we'll write x dash, y dash, z dash. 1 will be here to write the diagonals only, x, sx, sy, sz, 1. So other places you fill with zeros of x, y, z, and 1. Now to decrease the size, if you want to decrease the size, then same thing, instead of sx, you write 1 by sx. So 1 by sx, 1 by sy, 1 by sz, and 1. Other places you fill with 0 of the into the coordinates. Now the reflection. So reflection about the plane. So in which plane you are finding the reflection. So here along the xy plane. So you have to find out the determine along which plane you are finding the reflection. So along, if it is along the xy plane means, then x nu, you need to remember this, x nu will be equal to x old, and y nu will be y old, and z nu will be minus z old, because as I told, in the other xy plane means z will be negative value. So here z nu will be minus of z old. So here I will write x, y, z alone is minus 1, and then others is 1. So the new coordinates will be x, y, x dash, y dash, z dash. It will be equal to 1, 1, minus 1, 1. Other places are zeros, and of x, y, z, and 1. Same thing on the yz plane. So yz plane, how will it be? It will be like only x nu will be minus of x whole. So first portion only minus 1, other will be the same, 1, 1, and 1 of the current value, that is x, y, and z. So similarly along xz, along the xz plane, how it will be? It will be x nu will be x old, y nu will be alone negative. So y nu will be minus y old, z nu will be z old. So new coordinates will be equal to 1. So since y is negative, minus 1, 1, and 1. So other places we fill with zeros of the current coordinates. Next, rotation. Now rotation to along the x-axis. Along the x-axis. Rotation along the x-axis. Rotation means it will be x dash, y dash, z dash. 1 is equal to. So here how we'll do? We have to, if it is along the x axis rotation means the first row and first column you fill with zeros. So here in the diagonal it will be 1 only. So here this is 1 and this is 1, and the remainder write the values. See cos theta minus sin theta cos theta. You fill up in the middle. And then here also in the end also it will be 0. The other place will be 0, and then the diagonal will be 1. Similarly for y-axis rotation. Y-axis rotation means how we'll write? We'll write like, that is the second column and second row will be zeros. Okay, don't fill any values. So first, so take the cos theta minus sin theta cos theta. So here too it will be zeros, and then down bottom also it will be zeros and 1. Next, z-axis rotation means here it will be the third, that is the third column, and third row will be zeros. So you have to write the values here. So cos theta minus sin theta cos theta, other values will be 0, and since the diagonal is there, so write 1 here and 1 here. So other places zeros of the current value. Now 2D sharing and 3D sharing will be different. Okay, so that's why I compare and study 2D sharing and 3D sharing. See, for 2D sharing, but it's about the x-axis sharing. About the x-axis means the new coordinates will be x-axis should be x plus shx of y. So you have to write the sharing factor, that is shx of y, and y dash should be y. It is be the same. So I will write in matrix form x dash y dash 1, and here you write as 1 0 0 shx of y. So second in the second column you write shx, then the diagonals will be 1 only. of x, y and 1. Similarly, about the y-axis. So about the y-axis, how it will be, y dash will be y plus shy of x, and x dash will be x the same. So here how it will be, like x dash y dash 1 equal to 1 xhy. So x sharing pattern will be in y multiplied in the x value. So shy becoming the first column, that is shy, and 1 0 0 0 1. So diagonals will be 1. Okay. Next, about both the x and y axis means, then x dash will be x plus shx of y, and y dash will be y plus shy of x. So here the values will be x dash y dash 1 equal to 1 shx and 0 shy 1 0 and 0 0 1 of x, y and 1. Similarly, make a note of the 3D sharing. See, sharing in the x-axis. Here x new will be equal to x old. So y new will be equal to y old plus shy. Here you have taken shx. Here you have to take the shy value, xhy value into x old. And z new also will be z old plus shz of the x old value. So this is how your sharing will be in the x-axis. The new coordinates will be this similar. If you write in the matrix form, it will be like x dash y dash z dash 1 in a homogeneous matrix, and then you write, see, the diagonal will be 1 only, and then here you have to write in the first column, that is 1 shy and shaz, because you write only shy and shz. So here shy and shz. Similarly, sharing in y-axis. So in y-axis, here the new value y new will be equal to y old, but x new will be what? X new will be x old plus shx of y old. Similarly, z new will be z old plus shz of y old. So when you write in the matrix form, here it will be x dash y dash z dash. The new coordinates will be 1 1 1 right and diagonal. Then you take the next value, the second column, write shx, because shx and shz. So shx then shz will come in the second column, and then others you fill with zeros. Similarly, sharing in the z axis. So x new will be equal to x old plus shx. Here we are doing sharing in the z axis. So z new will be equal to z old. The value will not be changed. For x new it will be x old plus shx of what? Z old. Y new will be y old plus shy of z old. So here x dash y dash z dash 1 is equal to 1 right diagonals, or diagonal will be 1, and the others you go to the third column. Third column write shx and shy. Here you write shx and shz. Here you write shx and shy. Okay, of the old value. Okay friends, computer architecture and programming language and graphics. These are the important formulas. These are basic formulas. There are more formulas, but these are basic ones which you need to, at least you should know these formulas not attempt the UGC NET exam. Okay, so please, if you like this, please like, share and subscribe to my channel. Thank you.